Hey, hi everyone. Uh, Everyone is a bit, मतलब नींद तो नहीं आ रही, feeling tired or something. So I've had some feedback about the session that I will share right away. Okay, it's gonna be a little bit of a knowledge dump, kind of like a college lecture kind of a thing. Well, that's what I've been told. So I love networking, so it was very interesting for me to set this up. But yeah, अगर किसी को बोर लगे, please raise your hand. Try to reclarify the concepts because every other slide is gonna build up on the previous slide, right? So if you miss one concept, then it will be difficult for you to understand the rest. Uh, with that in mind, let's get started. I am Rajat Khanna, as the slide says. I'm a software development engineer at CommerceIQ. CommerceIQ is a company with this tech team based out of Bangalore. We are a online retailer analytics platform. We help online retailers on sites like Amazon, Walmart to optimize their listings for better sales, right? Some features we have are letting them know their search ranking on certain keywords, or we help them bid for ad slots on these e-commerce platforms. The backbone of this entire platform is a scraping engine that I run by the name Browser Farm. Uh, this is a Kubernetes cluster with 4,000 nodes, and as Kubernetes is a distributed system, networking is a crucial part of it. And during the development of this, I discovered some aspects, and I thought they were fun, and I should share them with you guys, right? So moving along with the presentation, let's look at the prerequisites. An amazing job was done by Akansha, Krish, and Hemant to explain you the basics of Kubernetes. So I won't have to spend a lot of time explaining the prerequisites, but everyone here, I'm hoping everyone knows what a pod is, what a node is. किसी को नहीं आता हो तो मतलब that will speed up things. But I'll quickly just go through it. We all know what a Kubernetes API server is now. It is backed by the etcd store. There are a lot of controllers that manage the state of your Kubernetes cluster, right? So basically, Kubernetes, everything is managed through the API server. There is a state of the cluster that is stored inside the API server, managed by the etcd store, and what do you call? And we have something known as controllers, right? Now, controllers are basically abstractions that are a control loop and that have one job, that your desired state is equal to your current state, right? So what they do is they keep on checking, and if that changes, they take actions to make sure it is the same way. One example is that when we schedule a pod on Kubernetes, what happens is that firstly, your scheduler looks at the state change that a pod was scheduled. It will make sure, it will look into which node has the optimum capacity to start this pod, and will write back that state change to the API server saying that this is where this pod should run. So once that is done, again the kube proxy controller, that's another controller, will pick up that state change and would set up the appropriate networking for that pod to run successfully, right? So these are some of the concepts that you should be familiar with to understand the talk further. So I thought I'll just go through them. Now, coming back to the first networking concept, what is NAT? NAT is network address translation, short for network address translation. Every one of us, I'm sure, would have a broadband at their home, and we all connect, tens and hundreds of devices to our Wi-Fi every day without ever wondering how things are running in the background. So the thing is that initially when the internet was designed, it was not meant to run so many devices that we run on it today. So there were a limited number of IPs on the internet, right? And if we start assigning every device a public IP, it will become impossible to run the internet as it is right now. So this is a very old concept, but a very popular concept by the name NAT. What happens is that, and this some of you might have actually seen, if you're using an iPhone, Android, any phone, you go to your settings, check for an IP address, right? Everyone knows what an IP address is? Yeah. So IP addresses, there is something strange that happens if you write on Google, what's my IP? you will get a public IP, right? 49 point kare kuch. But on your phone, you will get 192.168.0.1 or something, right? This is because when your phone is connected to the Wi-Fi, it is been assigned a local IP, not a public IP, right? And the public IP is the IP of the router that is there inside your home, right? So for example, here we have a setup where two clients have 0.1, 0.2 IP. These are the local IPs, and the router has an IP of 49.62.58, and the internet, there is a destination that we need to go to, that is 8.8.8.8, right? So now we have a packet that is from the first client that is going to 8.8.8.8. When it moves from the client to the router, right now if you look at the packet, it says source 0.1 and destination 8.8.8.8. But the router is going to do a NAT and going to change the source from 0.1 to 49.62. The reason router does that is because 0.1 is now not routable on the internet, because every home has thousands of 0.1, 0.2 IPs. So if we send out that address, the internet would not know how to send the packet back. So what NAT does is it rewrites the packet and says that the source is actually 49.62. That is the public IP of router, and that is how the packet goes outside to the internet. If a response come back, router again, response mein aayega ki, destination 49.62.5.8, right? But NAT is smart enough to figure out ki that is not the true destination. Obviously, it's just a router. So it will rewrite the packet again and say that the destination is 0.1 and the packet would travel back to your client. Is this clear enough, or does this require a little more going into depth? Cool. With NAT out of the way, let us discuss the Kubernetes networking model. Kubernetes has an opinionated approach to how we can set up a network in Kubernetes. There are three fundamental rules that they have. The first one is that all pods can communicate with all other pods without NAT, right? The second one is all nodes can communicate with all pods without NAT. And the third one is the IP that a pod sees itself as is the same IP that others see it as, right? So at the end of the day, what the rules are saying is ki IP ek hi hona chahiye. If a node wants to talk to a pod, it should have that IP. If a pod wants to talk to a pod, it should have that IP. If the pod itself wants to know what's that IP, it should be the same IP, right? This might seem a bit little, very like a common sense kind of a thing ki ye to obvious hai. But these rules were designed in such a way so that developers like you can, code applications very easily. So typically when you're using Kubernetes and you're using IPs, right, you never think about the underlying details, right? That is because of these rules, right? Because a pod of a IP is, available to connect from anywhere, any other pod or any other, daemon set or anything. It becomes very easy for you to, program your application on top of it. But today we are going to see below in the network layer, how is Kubernetes managing that, right? So with these principles in mind, I will quickly go through the networking networking types we are gonna address today. The first one is container to container networking. That will be two containers inside a pod. How does container networking happens inside one pod, right? The second one is pod to pod networking. Now, how do two pods talk to each other? Now, pods might be scheduled on the same node or they might be on a different node. So we are gonna discuss both those cases. अगर अभी से नींद आ रही है तो बहुत मुश्किल होगी प्रेजेंटेशन निकालनी. तीसरी है pod to service networking. Now there we'll figure out how a pod talks to a service. And चौथी है pod to internet networking. How does the pod talk to the internet? And fifth है internet to pod. How does internet talks to the pod? That is, how do you host an application and talk back? We will try to cover all of these if time permits. If we have a time issue, then I will just quickly skip through the slides. हाँ sir.
Going through the demo round every.
हाँ यार, इसके बाद थैंक यू थोड़ी दिखाऊंगा.
Maybe आप सिर्फ theoretically address करोगे इनको and.
नहीं अभी मजा आएगा. देखो अब इसके बाद से मजा है. This was the last.
Difficult.
हाँ, so वही मैं कह रहा हूँ, कुछ क्वेश्चन और let's make it more interactive. Any doubt, कुछ समझ में नहीं आ रहा, पुरानी स्लाइड पे पीछे जाना है, कोई वो थोड़ी है, रूल थोड़ी है. नहीं करेंगे खत्म प्रेजेंटेशन, we'll go back. But सब इकट्ठे आगे बढ़ेंगे. Moving on, let's start with container to container networking. So typically when you see machine, this machine, or typical desktops we have at home, we see a VM with an Ethernet device, right? There is a networking port. All of us have been using that since the beginning of times. हम LAN की तार डालते हैं and we have internet on the machine, right? And we open our favorite browsers and open Instagram and scroll reels for hours. In reality, the networking that makes that happen is a bit more subtle, bit more complex. So let's dive into that. In Linux, everything, there is something known as a network namespace, right? A network namespace is a logical networking stack. It provides you with things like a routing table, firewall rules, and a network device, right? Everything in Linux runs inside a network namespace, right? Every process runs inside a network namespace. By default, every process that you spin up in Linux is allotted to the root network namespace. The root network namespace is the network namespace associated with the physical device on your system, right? So everyone clear on what network namespaces are, right? कि एक logical unit होता है, routing table वगैरह सब उसके ऊपर ही होती है. The root device has its own network namespace, right? In terms of Kubernetes, we are all familiar with what this is. This is a pod, and the pod has 2 containers. A very simple scenario. Now, for setting up Kubernetes, for running Kubernetes in Linux, every pod has its own network namespace, right? So that makes it easy. So, for example, here there is pod 1, and we want to route traffic from container 1 to container 2, right? So the pod is in its own network namespace, and therefore it has its own virtual Ethernet device and can talk to each other. We'll get into more depth in a while, but I want to start with an example. How many of us have developed applications with databases in it? Or have developed applications that talk to other applications? Local host पता है सबको, everyone uses local host करते हैं ना. So when we are running an application on local host, we run it on 8080 for example, या 9090 कोई भी port. Now I want to add database to my application. I will start a database. For example, if I start Postgres, I will start it on the port 5432, right? So, but when you want to connect your database, what do? You write database address localhost 5432, right? Now, वो कर क्या रहा है उस time पे? Both your database, when you're running it on your laptop, your database and your application is running in the same network namespace. That is why your application is able to talk through localhost to the database, and the database is able to answer back, right? So similarly, for container to container networking, it is very simple that every pod has one IP, and if 2 containers inside a pod want to talk to each other, all they need to do is talk on localhost, right? For example, if container 1 is our application server and container 2 is a database server, he will connect through localhost to container 2, right? So that is how container to container networking is very simple. It happens inside a pod and runs on localhost. Is this clear, or was that confusing for anyone?
That means आप container 1 में जाके you can ping the containers to the IP, right?
1 में जाके मतलब दोनों का नेटवर्क डिवाइस एक ही है. तो जैसे आपके लैपटॉप पे आपका डेटाबेस और आपका एप्लीकेशन एक पे काम करता है ना. यू कांट हैव बोथ द कंटेनर्स रनिंग ऑन सेम पोर्ट, अदरवाइज वो पॉसिबल नहीं है. लैपटॉप पे भी नहीं होता. बट वो दोनों का नेटवर्किंग डिवाइस एक ही है, तो वो लोकल होस्ट के थ्रू बात कर सकते हैं, जैसे आपके लैपटॉप पे आपका एप्लीकेशन और डीबी बात करता है. ठीक है.
अगर लोकल होस्ट सेम रहता नहीं, जैसे हम डिफाइन करते हैं 127 आईपी रहती है, हाउ शुड आई डिफाइन कि ये डीबी है एंड माय एप्लीकेशन?
यार हम डिटेल में हम डीबी वगैरह की मैं एक एग्जांपल दे रहा था, मतलब कुछ भी हो सकता है.
मतलब मैं कंट्रोलर के पॉइंट ऑफ व्यू से
क्या चीज
एग्जैक्टली, अगर कंट्रोलर 2 है एंड आई एम पिंगिंग फ्रॉम द कंट्रोलर 1,
कंट्रोलर नहीं कंटेनर है ये.
सॉरी कंटेनर, हां फ्रॉम द कंटेनर 1 अगर मैं पिंग करता हूं कंटेनर 2 को, तो मुझे कैसे एग्जैक्टली पता चलेगा लोकल होस्ट की 2 को मुझे रीच करना है?
Container 2 should be
2 के पोर्ट अलग होंगे. 2 would be host exposing ports 5432 और SQL का क्या होता है, I don't remember, and है ना. हाँ, और 1 के अलग होंगे, तो वो एक दूसरे से
बेसिस ऑफ पोर्ट,
हाँ पोर्ट से बात करते हैं, क्योंकि नेटवर्क इंटरफेस तो एक ही है. और सेम पोर्ट्स पे 2 कंटेनर चल भी नहीं पाएंगे, क्योंकि वो आपके लैपटॉप पे भी इफ यू आर रनिंग एन एप्लीकेशन एंड यू रन अनदर एप्लीकेशन, तो वो एरर देता है कि द पोर्ट इज ऑलरेडी इन यूज, राइट. हाँ, तो बस वही वाली यहाँ पे भी वही सिनेरियो बनेगा, राइट. Is that fine?
Yes.
Okay. So with that out of the picture, there is a blue line signifying they're able to talk. Happy. Let's move on to pod-to-pod networking. Right. Now we get a little, dangerous. Abhi to nahi waise, but theek hai. In Kubernetes, every pod has its own IP as the rules state, right? Every pod should be discoverable to every other pod from that IP, discoverable to every other node from that IP, right? So this is now this will be another example where we have two network namespaces, pod 1, pod 2. Both are running 2 containers each, right? And our source would be the animations both dhire aa rahe hain. Anyways, our source would be pod 1 and our destination would be pod 2. Let's see how this networking happens. In Linux, we have something known as Linux Virtual Ethernet Device or Linux vEth pair. The purpose of this virtual Ethernet device is to connect different network namespaces, right? So here what we have is, now what I was discussing earlier, every pod has its own Ethernet device, right? वो इसके through बात कर रहा है इस पे, ETH के through, right? And pod is only aware about ETH0 in every pod, right? What happens is these Ethernet devices through virtual Ethernet device pair is connected to the root network namespace, right? And through that, it is able to route traffic to the root network namespace or the internet, right? Is this simple? Is this complex? एक simple tunnel है. It's a simple network tunnel that connects to different network namespaces. Okay. अभी से बोर हो रहे हो क्या यार? इतना ठीक है, थोड़ा बहुत सह लो, मतलब अच्छा है, आगे मजा आएगा. मतलब सर्विसेज में मजा आएगा, सीरियसली कुछ मतलब विल सी कि कैसे काम करता है वो. मुझे भी आया था, मैं इसलिए बता रहा हूँ. So now, but our problem was still remains कि we wanted pod 1 and pod 2 to talk to each other, right? वो हमने achieve नहीं किया था. For that, we use something known as a layer 2 bridge. Now, what layer 2 bridge does is that it connects two different network segments, right? Now, people in college or even professionals would have studied the network model, layer 7 model, right? There are network में there are layer 2, layer 7s. ओ ऐसा है, हाँ हाय कैसे निकला था वो पेपर. तो अब उसमें क्या होता है कि if you remember, just try to recall, layer bridge runs on layer 2. The problem with layer 2 is it is not aware of the IP, right? IP addresses it doesn't know about the IP addresses. So here the bridge runs a protocol called ARP, Address Resolution Protocol, right? So for starters, what we'll see, the packet travels from the vEth pair to the root network namespace, from there to the bridge. Now let us dive deep into what happens in a bridge. And even though here we have a Linux virtual bridge, this happens in real life also, at your home, in the networks, in your colleges. When you used to go to computer labs, you would see a network, some kind of a network switch on top, right? वहाँ पे वो bridge होता है, and this is how it is working. Bridge works on layer 2, and bridge is not aware about the IP addresses. So what bridge does is that it needs to find the IP addresses and then maintain a lookup table, right? For example, here our source is 192.168.0.1, destination is 192.168.0.9. The packet would leave from the bridge from 0.1, reach the bridge. Now the bridge has no idea, because bridge is a layer 2 device, it only knows ports and MAC addresses. MAC addresses are the physical addresses of network devices, right? So what bridge will do is it will forward the packet to all three destinations, all the ports, right? And then port on the 09 would answer back saying that this is my IP, right? The moment that happens, a lookup entry is added in the ARP lookup table that maps 0.9 to the MAC address of 26. And that is how routing on layer 2 works, right? This similarly, if we want the bridge will perform similar functions and identify that 0.2 is in the 28 MAC address and 0.10 is the 29 MAC address, right? Coming back to what we were discussing, that was pod-to-pod networking. Here your VM might have 5 or 6 pods. Very similar scenario, just the way like it works at your home, it will work here. Your VM might have 5-6 pods. Each of them would have a different IP address and a different MAC address. Virtual Ethernet devices also have those, right? And the bridge will have to figure out initially with that where is that what is the MAC address of pod 2. So it will send out a packet to all the pods, and pod 2 will answer back saying ki, this is my IP address. It will add the entry to the lookup table, and the packet will flow forward to VETH1 pair. From there, it will flow to the ETH0 network device, and from there to the pod 2 network namespace. Is that clear? मतलब थोड़ा समझ में आया या थोड़ा खो गया? ठीक है, ब्रिज था, मतलब वो लेयर 2 पे चलता है, इसलिए वो समझाना जरूरी था कि वो लेयर 2 पे कैसे करता है.
तो अगर बहुत ज्यादा corresponding to each pod,
हाँ, मतलब
उसके बाद ही communication possible होगा.
हाँ, फर्स्ट टाइम आपके घर के नेटवर्क में भी यही होता है, बट इट इज वेरी वेरी क्विक ना, इन मिलीसेकंड्स. हाँ, every time a new network you add, first packet is broadcasted to everyone, and then one device answers back saying, hey, I am 0.6, and the bridge just adds an entry. You can read about it. It's ARP protocol, address resolution protocol. It is used every day. Okay, anyways, is this clear? Yeah.
So can you explain that part again? I mean, after this bridge, right? Once
After
we starts in process, right? We get one MAC address of ETH0, which is the VM.
So after ARP happens on bridge, right, it will send the packet out to all the pods जो उस machine पे है.
So it will have a record of this machine VM.
Come again?
So it will have a record of machine, right? It's VM. And inside that VM, we also have more pods.
नहीं, it won't. Machine पे तो हम बात ही नहीं कर रहे. Forget the machine right now. It will have record of all the pods, right, in the lookup table. It will have a record of.
Each pod, it has to go through a.
Can you use the mic? You're becoming very.
But to reach a pod, right, it has to go through the ETH0, which is for a VM, right?
Yes.
So the bridge has to know which node first it has to go, and then from which node to which pod it has to go, right?
So we're right now talking about pod-to-pod networking on the same node. Next slide is about pod-to-pod networking on two different nodes.
Okay.
Right now this is in the same node. Give me a second. I'll come back to you if you're still not able to understand. We'll discuss this. So exactly what I mentioned right now. This was the half scenario where your source and destination pods are on the same machine. Now we're going to talk about what happens when your source and destination pods are on different machines, right? So now we have a VM1 that is having two containers, and pod 1 has one container, right? And now VM2 also has two pods, and pod 4 has another container. And there is an internode network that connects all of these machines, right? So source and destination is pod 1 and pod 4. Was this what you're talking about?
Yeah, I was getting confused. I thought that those are two different VMs.
No. That was one VM, but two pods on the same VM. Because VM pods can be anywhere, right? It can be on the same VM as yours or different VM, right? So now we all are aware of the typical flow. What happens? We know what we are very smart. We know how bridge works, right? So the packet would go up to the bridge, and now something interesting will happen at the bridge, because our destination pod is on the VM2, right? So the bridge would send broadcast a packet asking for the MAC address of certain IP, and you won't find it because that pod is obviously not on that VM, right? In this scenario, what the bridge does is it sends the packet down the default path, right? And the default path is ETH0. That is the physical interface of the machine. Now, the internode network here, right? That is the network connecting all the nodes, takes care of routing that packet to the correct VM, right? This is taken care by on a physical network by the network itself, on cloud providers like AWS, AKS, GCP through the cloud provider itself. One thing here that I want to point out is that if you are understanding how this is right now, a very interesting fact to see is that it is said that it is very important to decide maximum number of pods that you can run on a node before setting up the cluster. But if you observe carefully, you will see the reason as to why that needs to be done right now. Because every VM has a certain CIDR block that it runs in, right? CIDR block meaning ki we already know ki, sorry?
Range of IPs.
Range of IPs, right? Because if right now I started a Kubernetes cluster where I think I will maximum need 10 or 20 pods, and tomorrow I need 100 pods, it's not possible because my network was not planned that way. So when we plan the network with with thousands of pods, what will happen is every machine would be pre-allocated a certain set of IPs. That is a CIDR block, right? And that will help the Internode network to figure out where to send your packet, right? ठीक है, खो गए. ठीक है, अभी थोड़ा मस्त भी आएगा. अगर नहीं भी आया तो you can read more about it, but थोड़ी some fun things will come, right? So this is how a packet transfers through. It will go down. It will reach the bridge of pod 4, and it will go down the bridge. The bridge would do another ARP. It will find out the correct MAC address, and the packet will flow down to pod 4 network namespace.
लेफ्ट साइड में नोड है PR0, उसके पास राइट पोर्ट 4 का मैक एड्रेस कैसे पहुंचेगा?
उसके पास नहीं है. Every machine would only know the MAC addresses and the IPs that the pods that it is running. If it doesn't know if it does not find the MAC address for the IP it wants to go to, it just sends that packet down to the default route. That's what I said, ना? अगर नहीं मिलेगा तो E0 पे जाएगा, जो VM का default port है. And after that, the network takes care of it and send it back to VM2.
Let's say if there are thousands of nodes, उस केस में सभी nodes पे वो पैकेट्स जाएगा and then जो destination है वो find होगी और तब वहाँ पे पहुँचेगा.
कर रहे. We are doing this on internet every day. When we are connecting millions of devices, we are doing this every day.
But अगर वो एक टाइम में पहुँच जाता है, उसका फिर कैशे मेमोरी में जाता है.
ARP lookup table काम आता है ना, because if you don't have a lookup table, you will be doing this all day and you will be never reaching 1 Gbps. मुश्किल से 100 Mbps पे चलेगा. Because there will be a lot of collisions. सारे पैकेट सबको जा रहे हैं. For that ARP table that I talked about earlier is very useful.
ARP table is corresponding to
every bridge. Every bridge has its own local copy of ARP table.
Node.
हाँ, definitely. Is that good enough?
Yes. Yeah.
Chalo. Okay. So this sums up our pod-to-pod networking. Before moving into Kubernetes, pod to service networking, a brief introduction about what a service is. I think it has been covered very deeply in the slides before, but कर रहा हूँ यार, कर रहा हूँ. हाँ, तो मतलब मैं फटाफट बोलूँगा because everyone knows what a service is, right? Kubernetes service. Chalo, I'll just read through. A Kubernetes service allows you to track a set of pod and IP addresses that are dynamically changing over time. Services act as an abstraction over pods and assign a single virtual IP address to a group of pod IP addresses, right? Any traffic addressed to the virtual IP of the service will be routed to the set of pods that are associated with the virtual IP. This allows the set of pods associated with the service to change at any time. Clients only need to know the service's virtual IP, which does not change. Quickly summing up, service के पीछे 3-4 pods होते हैं, right? You don't want to code your applications to a pod IP because, as Chris was talking about earlier, I don't know where Chris is, but hi, pods are ephemeral, right? So pods can be created or destroyed at any time. So imagine if there was no service in Kubernetes, you will have to, find out the pod's IP every time you want to connect to a service. You will have to do the service discovery mechanism on your own, which would be very tedious, right? That is why services are very important in Kubernetes. They help you go to an application directly without worrying about the implementation. Now, one thing to note from this slide is that every service is a virtual IP. Virtual IP matlab it does not exist. It is not in the network, right? But now how does Kubernetes handle that? We will have a look now. So this is an interesting problem. This was the one I was talking about, right? Before we talk about KDS service routing, we need to understand a few basic concepts. NetFilter, it's a Linux framework that helps you do packet manipulation, allows networking related operations in the form of customized handlers. It performs functions like packet filtering, network address translation, port translation. So you remember NAT that I explained in the first slide ki kaise wo IP ka source destination change hota hai. That is primarily in Linux done by NetFilter. That is inside Linux, right? Now NetFilter is also a root level tool, so it is very difficult to use directly. NetFilter is used by something known as IP tables. Now, how many of you have used IP tables in Ubuntu 18? Ubuntu 18 use kar rakha hoga. Old Ubuntu versions, right? नहीं कर रखा कोई नहीं. Old versions of Linux, now Linux, I think Ubuntu has UFW, but previously IP tables used to be the primary firewall. अगर कोई पुराना DevOps का बंदा होगा, he would have spent years on IP tables, right? So what is IP tables? IP tables is a user space program providing a table-based system for defining rules, for manipulating and transforming packets using the NetFilter framework. The definition is too boring. मैं example से समझाता हूँ. Suppose करो there is a source and a destination, and in between there is IP tables. The source wants to send the packet to destination 1. The packet is gonna reach IP tables. IP tables is a क्या है table based system, right? So there is a list of rules in IP tables और उसको वो follow करता है packet को आगे भेजने से पहले. So IP tables has a rule saying every packet that is supposed to go to destination 1 will go to destination 2. उसमें एक rule है set IP tables के अंदर. In our example, when this happens, the destination, if you see carefully, has now been changed from destination 1 to destination 2, and the packet would reach destination 2. Is IP tables clear to everyone? User space का Linux का program है, and it is used to create rules कि अगर इस IP को एक पैकेट आता है जो इस IP के लिए आता है उसको वहां नहीं यहाँ भेजेंगे. अगर एक पैकेट आता है जो इसके लिए आता है उसको वहां नहीं वहां भेजेंगे. इस तरह के रूल्स लिखे आते हैं टेबल के अंदर. इट्स अ टेबल बेस्ड थिंग. बहुत सारे रूल्स होते हैं. हर एक पैकेट को उन रूल्स के थ्रू फिल्टर किया जाता है एंड इंश्योर किया जाता है कि उनमें से किसी भी रूल्स में वो पैकेट ट्रैप ना हो रहा होता है तो वो पैकेट का सोर्स या डेस्टिनेशन रीराइट किया जाता है. नहीं हो रहा होता तो आगे चले जाता है. हाउ दिस इज वेरी यूजफुल टू अस वी विल सी इन द नेक्स्ट स्लाइड. Let us move on to pod and service networking. Pod and service networking का एक example है. Just look at the diagram very carefully. This will be very helpful. There is a VM1 and VM2. VM1 has 4 pods. VM2 has 2 pods, right? Here are, again, let's discuss the source and destination. Source is pod 6. Destination is service 1. Everyone has used the service in Kubernetes, right? Service 1, service का you get the
node port.
हाँ नहीं उनकी बात हम नहीं करेंगे अभी, डर जाएंगे हर कोई. तो हम सर्विस की बात करते हैं. तो every service has an you route traffic to a service. The service is backed by pods and the traffic goes to one of the pods, right? Service ऐसी काम करती है. Now in this diagram, pod 6 is the source and destination is service 1. Let's see what happens. The packet will go through to the VETH1 pair, would go to the bridge would do an ARP, bridge would not find the IP for that, bridge would send that packet forward to ETH0, right? That is what we have learned till now, right? Now something I was hiding from you guys earlier to not scare you was key bridge, between the bridge and the Ethernet device of the root network namespace, there is IP tables. Now, why do we need IP tables here? Anyone can guess this?
To secure.
So I pointed out something very essential in the previous slide कि सर्विस का IP virtual IP होता है. It is not a real IP. You can't reach it, right? नहीं बता रहा हूँ. तो क्योंकि वो IP exist ही नहीं करता, if we send that IP down to the Internode network, it will never reach anywhere. The service would not work. So actually, what we think that service is this magical thing that automatically routes our packet. What happens is whenever your packet is leaving your virtual machine for the service, it goes through IP tables. IP tables has a rule saying, if you look at the service 1 abstract on the top, service 1 is backed by pod 2 and pod 4, right? So there is a rule in IP tables on every node saying कि any packet that is leaving the virtual machine addressed to service 1 needs to be rewritten, and the source and the destination needs to be rewritten from the virtual IP of service 1 to either the IP of pod 2 or pod 4, right? So if you look at the source and destination carefully at the top corner, right? When the packet reaches IP tables, the destination was changed from service 1 to pod 4, right?
Right.
ये बहुत जरूरी है समझना. मतलब प्लीज 2 मिनट ये सुन लो और कुछ सुनो ना सुनो, बहुत बढ़िया है. यार IP tables क्या करता है कि वो you have rules in IP tables कि मतलब कि अगर मैंने अभी बताया था कि अगर डेस्टिनेशन 1 है तो उसको रीराइट करके डेस्टिनेशन 2 कर दो. अगर सोर्स A है तो उसको रीराइट करके, मतलब नेट फिल्टर के थ्रू पैकेट रीराइटिंग करता है IP tables, राइट? रूल्स हैं कि इसको यहाँ भेज दो, इसको यहाँ भेज दो, राइट? अब वर्चुअल सर्विस 1 एक धोखा है, धोखा समझते हो कि वो उसका आईपी एग्जिस्ट ही नहीं करता, तुमको बताया जाता है कि वो आईपी है ताकि तुम खुश रहो, तुम्हें लगे आईपी है, सर्विस है, लेकिन वो एग्जिस्ट नहीं करता, तो उस पर पैकेट कभी राउट नहीं हो सकता। तो कुबरनेटिस चुपचाप क्या करता है, हर एक मशीन पे आईपी टेबल चलाता है और हर एक मशीन पे रूल प्रोपोगेट करके रखता है कि जब भी कोई पैकेट सर्विस 1 के लिए जाएगा ना, उसको तो उसके पीछे के पॉड है ना उन पे भेज देना, नहीं तो यूजर रोएगा कि सर्विस चल नहीं रही। ठीक है, इज दैट वेरी वेरी क्लियर? मतलब मैं इससे ज्यादा क्लियर मैं कुछ नहीं कर पाऊंगा, मतलब नहीं है तो फिर कोई नहीं, मतलब आईपी मतलब बहुत फन है। मैं भी कह रहा हूँ कि मैंने भी जब पहली बार पढ़ा था, आई फेल्ट लाइक कि वाओ, आई मीन आई वाज रियली टेकन अबैक फ्रॉम इट कि इट मेक्स सेंस बिकॉज आई डू नेटवर्किंग एट माय होम एंड ऑल एट फॉर फन, एंड आई वाज लाइक ऑफ कोर्स इट मेक्स सेंस कि वो कैसे मैनेज करता होगा, राइट? Anyways, this is how a service works in Kubernetes, right? And this is how the networking part of service works in Kubernetes. This is all done by Q proxy, जो पहले presentation में आपने देखा है कंट्रोलर है ना, तो वो ये सब हैंडल कर रहा होता है। Let's move along. तो इसमें क्या होगा कि वो पैकेट मस्त ईच से बाहर जाएगा, इंटरनोड पे जाएगा, वहां पे जाएगा, वहां के आईपी टेबल पे जाएगा, वहां पे ब्रिज पे जाएगा, ब्रिज पे ARP मारेगा, ARP से उसको पॉड 4 का नेटवर्क नेमस्पेस मिलेगा और वो वहां पहुंच जाएगा। Is this path clear to everyone? अभी वही आधी पीपीटी बची है, तो बहुत बची है, तो इसके बाद इंग्रेस एग्रेस सब बचा है। 5 मिनट फटाफट चलते हैं, ठीक है? ये सबको समझ में आ गया ना? नहीं आया तो बाद में पूछ लेना, मैं सब पूछूंगा नहीं क्योंकि फिर ये मारेगा मेरे को, ठीक है? तो सॉरी क्या let's go back now. अभी लेकिन we have covered this. We also need to cover the response journey that is equally crucial, right? So let's clear the path and let's swap the source and destination. Now imagine this, that you are sending a packet to service 1 that is actually pod 4. The pod 4 also needs to answer back to you, right? How would that happen? So we have swapped the source and destination. This is the same scenario we were in earlier, but now pod 4 is responding back to the request from pod 6, right? What will happen is वो पैकेट मस्त घूमेगा, बीच से जाएगा, ब्रिज पे जाएगा, घूमते फिरते हुए नीचे पहुंचेगा IP. It will reach the IP tables of virtual machine 2. Now something important that needs to be done here is pod 6 was expecting a response from service 1. It was not expecting a response from pod 4, right? So if a pod 4 packets goes through, pod 6 will be well, there is a term I can't use it, right? So pod 6 will be like, मैं तेरे को जानता नहीं भाई, why are you responding? I was talking to service 1. So here IP tables will do its magic again, and it will rewrite the packet, and it will change the source. If you go look at the top right corner, the source right now is pod 4 and destination is pod 6. It will rewrite the source from pod 4 to service 1, and then this packet would go forward. And for pod 6, it will be like service 1 was asked, sent a packet, and service 1 responded to the packet. And pod 4 is not pod 6. It will be like it sent a packet and respond the packet, and pod 6 will not be wiser. It won't be able to figure out कि वो actually से pod 4 से आंसर आ रहा था. Is this clear? ठीक है, भागते हैं थोड़ा सा. पॉड टू इंटरनेट हो जाएगा, 5 मिनट में हो जाएगा, 5 मिनट्स है ना. पॉड टू इंटरनेट नेटवर्किंग, देखो फिर से वही कहानी है. हमारे आईपी टेबल है, हमारा ब्रिज है, मैं दोबारा समझाऊंगा नहीं, ठीक है. नाउ समथिंग इंटरेस्टिंग हैपेंस हियर. दिस नाउ वी आर टॉकिंग अबाउट अ केस वेयर पॉड वांट्स टू कनेक्ट टू एन आईपी ऑन द इंटरनेट, ठीक है. अब इसमें क्या होगा कि मस्त पॉड पैकेट जाएगा, ब्रिज पे जाएगा, वीथ पेयर से जाएगा, आईपी टेबल्स पे जाएगा, ठीक है. पर अब now we are in a problem. We want to reach the internet by IP like 8.8.8.8 or some IP like that. We won't be able to get that IP because अभी तक according to what we have studied till now, there was no way to reach the internet, right? So now there is a lot more to explain, but I will just wrap it up. Your cloud provider, it may be AKS or AWS, doesn't cares about Kubernetes, not in the literal sense, but does anything special for Kubernetes, right? Cloud provider को पता है अपने nodes के बारे में, right? It knows that you have 20 VMs installed, and those 20 VMs have 20 IPs, right? So cloud provider does not care कि you are running Kubernetes inside or you are running a monolithic inside. So what is required to happen here is that IP tables will rewrite your packet this time, but it will change the source from pod 1 to the VM's IP, right? Is this clear? Why this needs to happen? क्योंकि packet को इस बार बाहर जाना है. It's not about inside Kubernetes, right?
पोर्ट के आईपी से भेजने में क्या प्रॉब्लम है?
पॉड का जैसे आपके घर में हम जैसे 0.2 बाहर नहीं जा सकता.
पोर्ट को वर्चुअल मशीन का ही आईपी मिल रहा है इवेंचुअली, राइट?
पॉड को नहीं मिल रहा, आपके पैकेट को मिल रहा है. पॉड के पास तो अपना आईपी है ना.
VM की पब्लिक आईपी से रिप्लेस हो जाएगा ना.
हाँ, VM के पब्लिक आईपी से रिप्लेस हो जाएगा, है ना. और अगर ये VM एक प्राइवेट VPC में चल रही है, जो समझते हैं ठीक है, जो नहीं समझते कोई नहीं, तो वो आगे एक इंटरनेट गेटवे पे जाएगी, है ना. अब इंटरनेट गेटवे का भी वही सीन है कि भैया इंटरनेट तो क्योंकि प्राइवेट VPC था तो वो VM का आईपी तो इंटरनल है. दोबारा रीराइटिंग होगी पैकेट की और वी विल रीराइट चेंज द सोर्स फ्रॉम VM1 IP टू इंटरनेट गेटवे IP. तो सोर्स देखो ध्यान से, सोर्स 2 बार चेंज हुआ, बट समझ में आ जानी चाहिए बात बेसिकली कि वो हर एक लेवल पे आईपी का सोर्स आईपी चेंज होगा, क्योंकि इफ वी डोंट चेंजेस द नेटवर्क आउटसाइड would not be able to route the packet back. Now something similar would happen when the response comes back. First rewriting will happen on the internet gateway. It will rewrite from internet gateway IP to VM IP. When the packet reaches the E0 of VM1, rewriting will happen again, and it will rewrite from VM1 IP to the pod IP, और फिर वो IP table से तो नीचे जाके pod 1 तक पहुंचेगा. ठीक है ना, सबको आगे नहीं.
Because of the reason कि इंटरनेट नहीं जानता है कि कोई वर्चुअल मशीन में एग्जिस्ट कर रही है.
कुछ भी नहीं जानता इंटरनेट. तो इंटरनेट सिर्फ गेटवे को जानता है ना, और बाकी सब अपने हर कोई अपने अपने बंदों को जानता है, दोस्तों को जानता है, और वो पैकेट पास करके आगे भेज देता है. In this we use something. So for responses, for tracking the responses, there is a utility called con track. Not relevant, but that is used to track जो responses आ रहे हैं उनको rewriting में, कि याद रखने के लिए कि कौन से response पे क्या IP डालना है. Con track utility by the name con track is used. Anyways, last है
DNS टेबल, DNS का यूज
नहीं हम बात नहीं करेंगे उस बारे में, वरना मेरे को अरे 2 मिनट यार, लास्ट है इंटरनेट टू पॉड नेटवर्किंग. हो गया बस हो गया. इंटरनेट टू पॉड नेटवर्किंग डिस्कस कर रहे हैं, ठीक है. ये बहुत स्लो चल रहा है. तो ट्रेडिशनल ऐप्स में यू वुड हैव सीन कि जिसने भी कुबरनेटिस नहीं यूज कर रखा है पर वैसे यूज कर रखा है, एक लोड बैलेंसर होता है, 3 मशीन्स होती है, उन मशीन्स पे ट्रैफिक जाता है, इक्वली डिस्ट्रीब्यूट होता है और एप्लीकेशन पे जाता है, राइट. तो सिमिलरली यहाँ पे भी कुबरनेटिस में भी सेम ही चलता है. मैं फटाफट से बढ़ रहा हूँ आगे. कुबरनेटिस में भी सेम ही होता है. लेयर 4 पे लोड बैलेंसर पे पैकेट आता है, क्लाइंट है, सोर्स और डेस्टिनेशन है पॉड 3. अब इसमें क्या होता है कि ट्रेडिशनली लोड बैलेंसर को, बिकॉज लोड बैलेंसर इज अ राउंड रॉबिन लोड बैलेंसर, तो वो पैकेट किसी पे भी भेजेगा, राइट. बट योर डेस्टिनेशन इज पॉड 3. सो अगेन IP tables to the rescue. What IP tables will do is, if the packet comes to, for example, on the VM3 port, ये क्या हो गया? I think I'm pressing the wrong key. I'm sorry. If the packet comes to the VM3 IP tables, right? What it will do is it will obviously rewrite the packet again, and that packet will be sent to pod 3. So basically IP tables is done यहाँ पे. It does all the rewriting and makes sure that the packet goes the right way. Okay. With that in mind, let us sum up the presentation. ठीक है, you know all this pod VM1 internet gateway rewriting होगी फिर से, ठीक है. So we have covered all these right now except layer 7, because layer 7 is way beyond the scope right now. In container to container, we go through localhost in the same network namespace. In pod to pod networking, on the same node, we go through the bridge. On different nodes, we go through the Internode Network. In pod to service, we go through IP tables. In pod to internet networking, we go through internet gateway. And in internet to pod networking, क्या हो गया? In layer 4 we go through node port. Okay. In layer 4 we go through IP tables only. Avoid node port, that is not relevant right now. But does everyone has a brief idea of मतलब चलता कैसे basically IP tables, NAT? If you remember the core tools, you will be able to figure out कि packet कैसे trace हो रहा है. The reason this is kind of important is that when you're running a very big cluster, right? You need to understand these things to debug issues. There are thousands of VMs and you do get confused very easily. So having a knowledge of these core concepts help you debug things easily. Anyways, that was my time. Thank you so much to Thank you so much to CNC Delhi to not throwing me off.